Morning, ladies and gentlemen. Welcome to the video notes for the second of 3 lessons in the Euler Circuits and Paths unit. Again, this unit is introducing graph theory for the first time, so this information should be entirely new to you. That does not mean it is difficult. Please make sure you take your time, and if you have any questions, please do not hesitate to email them to me. So we've already discussed the basic terminology of graph theory. We did that late last week. If you have not turned in your assignment on that, please do so as soon as possible. But now we are going to discuss in particular what Leonhard Euler developed and what is now called Euler graph theory. And that is based on the idea of a couple new vocab words that we haven't put in place yet. So we'll try to do that here in this first video, is put all the vocab in place. And then in the second video I will show you how we will be using that on our next assignment. So the first vocab word we need to put in place is this idea of a path. A path is a series of adjacent edges from a starting vertex to a different ending vertex. In other words, it is us being able to travel from one vertex to a different vertex by way of adjoining edges, because again, adjacent edges are edges that share an endpoint. So down here we have an example graph. It contains a total of 8 vertices and a total of 8 edges, and it wants us to give a path from point B to point G. In other words, it wants us to start at B and it wants us to end at G. And that really shouldn't be very difficult. All we need to do is locate one set of edges that would get us from B to G. For instance, we could travel from B to A, then from A to E, E to F, and F to G. That path would get us from B to G. And the way that we list a path is we just list the vertices in the order that we're traveling. So we went from B to A to E to F to G. This particular path would be said to have a length or weight of 4 because it travels a total of 4 edges. Now there are other possible edges or other possible paths in there. For instance, we could do from B to D to A to E to F to G. That would work as well. So again, that was B, D, A, E, F, G, which again is a length or a weight. I'm going to use weight this time so you realize that those two words have the same meaning, of 5, because we traveled a total of 5 edges. There's one additional path we could have come up with from B to G. Actually, there's 2 more. We could have gone from B to A to E to F to H and then to G. So from B to A to E to F to H and then to G. Again, that would have a weight or a length of 1, 2, 3, 4, 5 edges. 1, 2, 3, 4, 5 edges. So a path is a series of edges that allow us to travel from one vertex to a different vertex. Now, there is a more specific term that we need to discuss. That term is circuit. A circuit is a path, but it's a special type of path. It is a path where the starting and ending vertex are the same. So in this case, we have a different starting graph. This one only has 4 vertices. It has a total of 5 edges, and it wants us to list circuits from point B. So that means we're going to both start and end at B. We're going to start and end at B. So we could do, for instance, B to A to D and then back to B. That would be an example of a circuit. That circuit would have a weight of 4. And it would be equivalent to BDAB. Those are the same circuit. Okay? So A different one we could do would be from B to C to D and then back to B. B, C, D, B. Again, that is also a weight of 4. And it is identical, it is the same as the circuit BDCB. There's only one more circuit in this picture, so let's go ahead and show it. That is a longer circuit that travels around the outside. B to A to D to C and then back to B. This one has a weight of 5 and is equivalent to BCDAB, which is simply traveling the edges in the reverse order. So circuit and path are two new vocabulary terms for us. They're not going away. We need to make sure that we understand those. If you have questions on either, do not hesitate to email me today so that I can help you clear up whatever your issue might be. Now, when it comes to Euler graph theory, there are even more specific terms called Euler path and Euler circuit. An Euler path is a path which uses every edge in the graph exactly one time. The graph above does not contain an Euler path. The graph from the previous page does contain an Euler path. If you want to go back to that graph, the path that would represent an Euler path would travel something along the lines of CA, BDA, EF, G, H, F. So it would start at C and end at F, or vice versa, and that would travel every single edge in the graph exactly one time. Now you'll notice that in that process we did visit a couple of the vertices A and F more than one time. That's perfectly acceptable. So again, if you're wondering where this is found, it's found on the previous slide, the previous graph. Okay, this graph right here has that as an Euler path. An Euler circuit is a circuit that uses every edge exactly one time. So on the graph above, the number 3 on the previous example is an Euler circuit. It uses every edge exactly one time. Oh no, it doesn't, I lied. That is not true at all, so disregard. That graph does not contain an Euler circuit. We will see an example in the next video of a graph that contains an Euler circuit, but that is not one because we don't use edge BD, so I apologize for that. That's not true. That does it for the first half of the video notes. Please make sure that you watch the second video with equal attentiveness. Thank you.